What if the rarest visitor our solar system has ever seen is not merely a comet, but a cryptic message, a cosmic riddle we are only beginning to decipher? Atlas is far from a silent phantom. It flares, blazes, and carves an incandescent path across the void. Unlike the frozen, inert objects we expect, Atlas is alive with activity. Its volatile jets and shimmering tail contradict everything astronomers believed about comets and cosmic debris. Only a handful of years ago, Oumuamua swept through our skies, a tumbling, cigar-shaped enigma that accelerated as if nudged by some invisible hand. Next came Borisov, a comet so brimming with unusual ices and alien gases that it defied classification. Each arrival shattered our scientific certainties, forcing us to rewrite the playbook of what can intrude upon our solar sanctuary. Imagine, if you will, an ancient wanderer, forged in the darkness between distant suns, now slicing through our celestial neighborhood at a velocity so overwhelming that not even the sun's gravity can halt its relentless passage. This is 3I Atlas, the third confirmed interstellar object ever observed, a massive, mystifying presence that arrived unannounced, defying all predictions and confounding our expectations. Yet Atlas dwarfs them all. Its nucleus stretches an estimated 10 kilometers across, far larger than any interstellar wanderer we have known. Its speed, nearly 58 kilometers per second, makes it one of the swiftest objects ever tracked. Its orbit is so wild and unbound that its origin can only lie in the abyss beyond our sun's reach. With every observatory straining to glimpse its secrets, a more unsettling question takes shape. Is Atlas simply another rock, or is it something stranger? A relic, a fragment, or perhaps even a silent signal from distant systems or civilizations? To grasp why Atlas matters and why this is not just another cosmic pebble, we must first unravel what sets these interstellar objects apart from everything that orbits our sun. The story of interstellar visitors begins with the impossible, objects that do not belong, traveling paths that make no sense. Before Atlas, each arrival upended what scientists thought they knew about the solar system's borders. In the cosmos, meaning often rides on what is left unsaid. The universe whispers its truths, letting them slip by too quickly for comfort, too bizarre for certainty. 3I Atlas may be our sole chance, perhaps in 1,000 years, to learn from such a visitor. If we let it pass unnoticed, we may forever lose our opportunity to pierce the boundaries of the familiar. Comets and asteroids, those familiar wanderers, usually remain loyal to our sun, drawn along invisible paths that repeat for eons. But now and then, something truly foreign arrives, an object moving so swiftly and strangely that it could only have come from the deep, uncharted dark between the stars. For countless generations, humans gazed up at the sky and believed it obeyed ancient, unbreakable rules. The cosmos seemed fixed, local, a grand clockwork whose movements offered comfort in their predictability. That illusion vanished as science cracked open the heavens, revealing a solar system adrift in an endless ocean of stars, each one a harbor for unknown wonders. Such visitors are called interstellar objects, cosmic nomads born in distant star systems, hurled across unimaginable voids to brush past our world before vanishing forever. In all of human history, only 3 have ever been detected. Both of these interstellar strangers arrived unannounced and departed before we could truly unravel their secrets. Each left behind more questions than answers, igniting debate and wonder across the scientific world. The first, discovered in the year 2017, was Oumuamua, Scout in the Hawaiian tongue. Oumuamua was like nothing else, a pale, tumbling shard with no tail or glowing cloud, slipping through the solar system with an acceleration that baffled even the most seasoned astronomers. Some dared to wonder if it was an alien probe, So strange was its behavior, and so stubbornly did it defy natural explanation. The second, Borisov, appeared in the year 2019. Borisov looked more familiar, a comet trailing a luminous tail, but its chemistry was utterly alien, containing rare ices and burning with a ferocity unknown among our own comets. Its very substance hinted at origins in a frozen, far-off cradle beneath another sun. Now, as the third interstellar object blazes through our solar system, a massive, enigmatic body, we stand at the brink of discovery and loss. This may be our last chance for decades, perhaps centuries, to glean the secrets of a cosmic outsider before it vanishes into the black. Atlas is not just rewriting the record books, it is bending the very rules by which we understand the cosmos. With the arrival of this new interstellar visitor, the stakes have never been higher. What we learn, or fail to learn, may redefine our understanding of the universe and our place within it. First spotted in July of 2025 by the Atlas telescope in Chile, 3I Atlas was immediately flagged as an interstellar visitor. Its velocity is staggering, nearly 58 kilometers per second, vastly outpacing every previous cosmic interloper we have observed. In moments, astronomers realized this was no ordinary wanderer from our own solar neighborhood. Atlas is not just big and fast, it is alive with activity. A glowing coma shrouds its heart, and a faint, persistent tail flickers behind, a textbook cometary form. But unlike Borisov's violent flares, or Oumuamua's eerie silence, Atlas burns with a steady, enigmatic glow, refusing to fit neatly into any known category. Yet speed is only the beginning. What truly electrifies the scientific community is Atlas's sheer scale. Current estimates put its nucleus at close to 10 kilometers wide, a giant among interstellar objects, dwarfing both Oumuamua and Borisov by nearly an order of magnitude. Such size, crossing untold light years, raises urgent questions. How did it survive the journey, and where could something so massive have formed? Its trajectory tells an unambiguous story. Atlas is on a hyperbolic path, a true one-way traveler from the farthest reaches of interstellar space, destined never to return after its brief solar encounter. Its surface radiates a deep red tint, hinting at rare organic compounds, molecules shaped by unthinkable epochs in the icy darkness between the stars. With every sweep of the telescope, new mysteries accumulate. Why does such a colossal, radiant object remain so stable and subdued? What makes it so different from its interstellar predecessors? Astronomers now speculate that Atlas may define a new class entirely, neither asteroid nor classic comet, but perhaps an in-between, or even a category yet unnamed. As Atlas approaches its closest passage to the Sun, scientists race against time and distance. Every observation could be the key to unlocking secrets that have drifted through the galaxy for millions of years. But beneath the data and hypotheses, another, more unsettling question grows. Could Atlas, so perfect and so peculiar, truly be a product of nature alone? Or is it plausible, however improbable, that Atlas was crafted, designed to mimic a comet, carrying secrets from another intelligence far beyond our own? One truth cannot be denied. Our window for discovery is vanishingly brief. If we fail to study Atlas now, we may never again have the chance to probe the chemistry, physics, and possible origins of matter from beyond our solar system. This moment may be our only invitation to unravel a mystery that could redefine our place in the universe. Atlas's journey began before the sun itself. What ancient truths might it relinquish before it vanishes forever? Let us pause and ask ourselves, what are we truly witnessing? Atlas might be billions of years old, shaped in a time when our galaxy was but a fledgling swirl of stars. It may even predate our solar system, forged in the galaxy's primordial halo, a vast ghostly sphere where ancient ice and stone drift unclaimed, untouched by any planetary warmth. Yet, Atlas is no mere fossil. Its chemistry is a message echoing through the ages. Early spectrographic studies reveal complex organics, carbon chains, water, rare molecules. These are not just curiosities. They are the raw ingredients for life. If such building blocks are common out here, scattered across the galaxy, then perhaps life's recipe is not Earth's alone, but inscribed throughout the stars themselves. Still, Atlas refuses easy answers. Despite its enormous bulk and tremendous speed, its behavior is oddly subdued. Its tail glows, but not with the wild abandon of local comets. Gases escape, but not in familiar ways. Could it possess an unusually thick crust, exotic ices, or internal chemistry unlike anything in our solar system? Might it even carry imprints of cosmic events so rare we have never before recorded them? Around the globe, the astronomical community holds its breath. For the first time, professionals and amateurs synchronize efforts in real time. Every image, every spectrum, no matter how humble, could unlock the riddle of an object utterly unbound to our sun's story. Atlas is a wanderer that has never circled our star, nor felt the pull of our planets. It arrives as a messenger from realms we have never seen. Every glimpse of Atlas is a lesson in humility, a sharp reminder that the universe is far stranger than our best theories. The clock is ticking, and the window to learn from Atlas narrows with every passing hour. What will we risk? What might we gain if we dare to reach for its mysteries? The danger is real. Ignore this fleeting visitor, and we abandon our pursuit of cosmic origins. Questions echo. Where did we come from? Are we cosmic accidents or threads in a larger tapestry? Atlas is a once-in-an-epoch herald, and it will not wait for us to be ready. But this chance is heartbreakingly brief. Should Atlas slip by unstudied, we risk losing not just data, but the opportunity of a lifetime. We could forfeit our only chance, perhaps for generations, to decipher how planets are born, how deep space chemistry unfolds, and how life itself might ignite. The next interstellar visitor could be decades or centuries away, or so faint we overlook it entirely. For all we know, objects like Atlas are far rarer than we imagine, or perhaps they slip silently through the dark, escaping our notice. 3i Atlas does not simply add one more name to the short list of interstellar visitors. It breaks the patterns we thought were universal, upending decades of careful astronomy. Its chemistry, structure, and wild behavior do not fit the rules we built from a lifetime of watching familiar comets and asteroids. Atlas forces us to admit how little we know. Our textbooks tell a tidy story, but these outsiders, from Oumuamua's impossible path to Borisov's unearthly ices, make us confess how much of the cosmos remains hidden. Atlas, with its enormous bulk and blazing active coma, should not exist. Not if our old models were right. Its arrival has unleashed something extraordinary on Earth, a wave of collaboration unlike anything before. Professional astronomers scrambled for telescope time, yes, but so did amateurs, students, and citizen scientists. Whole networks sprang up overnight, connecting curious minds across continents and time zones. For once, open, global inquiry is not just a dream. It is the only way to keep pace with an object so rare and unpredictable. Atlas's wild activity punches holes in our deepest assumptions about what can survive the journey between stars. Some molecules in its vapor have never shown up in local comets. Its resistance to the sun's fierce radiation is baffling. If life's building blocks can cling to such alien icebergs, then the tale of how life spreads might be far messier and much more hopeful than we ever dared hope. And there are always stranger ideas. Could Atlas be a disguised messenger, or even an artificial probe? There is no real evidence for that yet, but even asking the question stretches both our imagination and our scientific rigor. Science only moves forward when we are brave enough to ask the wildest questions and relentless enough to test them. The rarity and variety of these interstellar visitors reveal a universe that is not neat, but wild and entangled. Each one comes from an unknown story, carrying clues about distant worlds, ancient collisions, and maybe, just maybe, the seeds of life itself. Our home is smaller than we believed, and the cosmos is far more chaotic than our neat diagrams ever showed. Whether Atlas is just a rock, a frozen relic, or something stranger, its brief crossing above our heads is humbling. For a handful of months, we stand at the crossroads of the galaxy, witnesses to a mystery that will soon slip away forever. Atlas will soon slip beyond our sight, but its challenge lingers. What will you do with your brief moment under its shadow? Atlas is not just a puzzle for scientists. It is a call to everyone willing to look up and wonder. As Atlas races toward the edge of the solar system, the chance to unlock its secrets is slipping away. If we let these moments pass, we lose more than measurements. We lose our sense of what is possible. To ignore Atlas is to turn our backs not just on discovery, but on the awe that launched humanity's greatest leaps. Curiosity is our greatest gift. If we let it fade, our place in the universe shrinks with it. Atlas's brief presence is more than a puzzle for astronomers. It is a mirror showing how we face the unknown. Do we accept the limits of our knowledge, or do we act before the moment fades? If we turn away, our greatest questions may vanish into the dark behind it, unanswered, and with them, our sense of cosmic wonder shrinks. At this closing hour, Atlas is no longer just a cold wanderer of ice and rock. It becomes a cosmic riddle hurled at us from the unknown, demanding not only what else is out there, but how boldly we dare to seek. Each time it brushes past our sun, we are reminded that the universe is not a finished tale. It is a living story, writing new chapters just beyond the edge of what we dreamed possible. This encounter is rare. Perhaps once in 100 generations will such a visitor arrive. If we let Atlas drift away with indifference, if we fail to ask the unsettling questions, we lose more than a scientific prize. We lose a piece of our restless human spirit, the part that aches to reach beyond what is safe, that yearns to understand mysteries just out of reach. Yet, if we choose to look up, to ask, to marvel, Atlas's passage can become a spark. It can launch new missions, awaken new dreams, and ignite new science. It can remind us that to be human is to refuse to let the unknown pass unchallenged. Our time in Atlas's shadow is fleeting, but if we reach for it, the echo of this mystery can shape generations. The next step is ours, to wonder, to search, and to never stop chasing what lies beyond. As Atlas races outward, never to return, ask yourself, will you let it be just another fading streak, soon forgotten? Or will you let it change how you see the universe and your own place within it? The rarest discoveries are not always answers. Sometimes they are invitations to ask better questions. Throughout history, civilizations have marveled at comets, often interpreting their appearances as omens. The Great Comet of 1680, for example, was chronicled by astronomers across Europe and Asia, inspiring both dread and curiosity. Yet even the most spectacular comets of the past, like Halley's, which returns every 76 years, are bound to our sun. None could have prepared us for the idea that a true outsider, born under another star, might appear in our skies. But let's go deeper. To truly appreciate the magnitude of Atlas's arrival, we need to consider the cosmic backdrop against which it unfolds. Our solar system is not a solitary oasis. It orbits within the Milky Way, a galaxy of hundreds of billions of stars, each surrounded by their own retinues of planets, moons, asteroids, and comets. The vastness between these stellar islands is dotted by drifting fragments, remnants of planet formation, survivors of titanic collisions, and, occasionally, objects ejected from their home systems by gravitational chaos. Consider the moment in 2017 when Oumuamua was detected. In just a few days, astronomers realized its trajectory made no sense. It was not orbiting the sun, but passing through on a hyperbolic path. It was as if a message in a bottle tossed from a distant shore had washed up on our cosmic beach. This fleeting visitor left as quickly as it appeared, prompting a flurry of studies and countless debates. Was it a fragment of a shattered planet, an icy shard from an alien Oort cloud, or something made, not born? Then came Borisov in 2019, shining with a familiar cometary tail, but composed of substances never before seen in our system. Its cyanide-rich gases, its peculiar dust, forced chemists to reconsider the diversity of planetary nurseries in the galaxy. In Borisov's wake, scientists began to ask, if such objects can reach us, how many more must pass unseen, too dim or too swift for our instruments to catch? Now, with Atlas, the questions multiply. Its sheer size is staggering. To illustrate, if Atlas struck our planet, a vanishingly unlikely event, it would deliver energy dwarfing the impact that ended the age of dinosaurs. That impactor, known as the Chicxulub asteroid, was about 10 kilometers in diameter, the same as Atlas. While Atlas will not collide with Earth, its mass hints at the scale of forces operating in distant planetary systems. Atlas's composition is a puzzle in itself. Early readings suggest the presence of complex carbon molecules, perhaps even polycyclic aromatic hydrocarbons, substances believed to play a role in the origins of life. Such molecules are not unique to Atlas. They have been detected in interstellar clouds and on the surfaces of comets like 67P Churyumov-Gerasimenko. But the fact that they have survived an interstellar journey, bombarded by cosmic rays and frozen in darkness for millions or billions of years, raises profound questions about the durability of life's precursors. This is not mere speculation. The concept of panspermia, the idea that life, or at least its ingredients, can travel between worlds on comets and asteroids, has gained new traction with each interstellar discovery. When the European Space Agency's Rosetta probe landed on comet 67P in 2014, it detected organic molecules and even amino acids. These findings support the notion that the universe is primed for chemistry, if not biology, on a cosmic scale. Imagine a scenario where billions of years ago, a planet orbiting a distant sun is disrupted by a passing giant. Its outer layers torn away, its children flung into the void. Some fragments, like Atlas, might travel for eons, crossing the gulf between stars. Along the way, cosmic rays would sculpt their surfaces, leaving behind exotic chemistry. Eventually, one piece finds its way to our solar system, a silent ambassador from a world we will never see. But Atlas is different. Its passage is an opportunity to test our most audacious ideas. Could life's seeds survive the long, cold exile between stars? Is it possible that on some distant world, a similar visitor delivered the spark that led to conscious beings? The late Carl Sagan once said, "We are made of star stuff." Each interstellar object that visits us is a chance to trace that heritage, to see if the blueprints for life are truly universal. A deeper historical parallel can be drawn to the discovery of Neptune. In the mid-19th century, astronomers noticed anomalies in Uranus's orbit. Through mathematical prediction and international collaboration, they found Neptune, an unseen world revealed by its gravitational tugs. Atlas, too, may point to new realms of understanding, not by its gravity, but by the secrets encoded in its matter and motion. Coordinated campaigns are underway to measure Atlas's rotation, its outgassing patterns, and its response to solar heating. Amateurs with backyard telescopes can contribute too. By recording brightness changes and sharing data, they help refine models of Atlas's structure and behavior. The global response is reminiscent of the Shoemaker-Levy 9 comet impact on Jupiter in 1994, when observations from around the world captured the drama in unprecedented detail. How do we seize this chance? The practical steps are unfolding now. Spectroscopes at observatories across 5 continents are dissecting Atlas's light, seeking signatures of rare elements and isotopes. Space agencies are considering rapid response missions. The idea? Launch a small probe to intercept Atlas, collecting dust, gas, and perhaps even surface samples as it speeds past. This is reminiscent of the Stardust mission, which in 2006 returned grains from Comet Wild 2 to Earth, revealing unexpected forms of organic matter and minerals forged at high temperatures. As Atlas brushes past the sun, we must act quickly. Its closest approach is measured in weeks, not months. After that, it will fade into the outer darkness, irrevocably lost to human eyes. The urgency is real. Missing this window means waiting for another, perhaps less accommodating, visitor decades or centuries hence. But there is hope. The James Webb Space Telescope, with its unmatched sensitivity, may capture infrared spectra of Atlas, revealing temperatures, ice compositions, and even the presence of rare or prebiotic molecules. Ground-based arrays, like the Very Large Telescope in Chile or the Keck Observatory in Hawaii, will provide high-resolution imagery and chemical analysis. Every instrument is pressed into service, every minute of observation precious. What would a successful encounter look like? Imagine a coordinated campaign, robotic probes intercepting Atlas, returning samples to Earth, laboratories racing to analyze the dust and gas for exotic isotopes, amino acids, or even microfossils. If even one molecule is found that cannot be explained by known processes, it would ignite a scientific revolution, redefining our sense of life's place in the cosmos. But the real impact goes beyond science. The spectacle of Atlas, visible to the naked eye as a faint, moving star, could inspire a new generation of explorers. Schools might organize viewing nights, artists might capture its fleeting beauty, and philosophers might ponder humanity's role as witnesses to cosmic history. Just as the Apollo moon landings galvanized a generation in the 1960s and 70s, so too could Atlas shape our ambitions for the next century. Let us not forget the sobering lesson of Oumuamua. Uncertainty lingers when opportunities are missed. For years, astronomers have debated its origin, composition, and even the faint possibility of artificiality. Had we been prepared, perhaps we would know more. Now, with Atlas, we have a second chance, a rare moment when preparedness and opportunity align. Above all, keep asking questions. Encourage curiosity in yourself and others. The true gift of Atlas is not its answers, but its invitation to wonder. In a world often obsessed with certainty, let's make room for awe, for the possibility that there is more to reality than we have yet dreamed. So, what can you do? Start by following the news. Share the story. If you have access to a telescope, join a citizen science campaign. Talk to others about what Atlas means, not just as a scientific oddity, but as a symbol of humanity's ceaseless quest for knowledge. Support funding for astronomical research, education, and space exploration. Every voice matters in building momentum for future missions and discoveries. As the days pass and Atlas slips farther away, reflect on this. Our encounter with it, however brief, is a reminder that the universe remains a place of surprises. We are, at heart, explorers, driven by the need to see, to know, and to understand. Atlas is a messenger from beyond, and by listening, we honor the best part of what it means to be human. Each scenario, natural or artificial, mundane or miraculous, demands our full attention. If Atlas is natural, it will tell us about the processes that shape worlds at the edge of the galaxy. If it is artificial, even in part, it would represent the first material evidence of other intelligences, a discovery that would reshape philosophy, religion, and science in ways we can scarcely imagine. The story will not end with Atlas. Someday, another wanderer will appear, Perhaps larger, perhaps stranger, perhaps carrying even deeper secrets. By then, if we have learned from Atlas, we will be ready. Our instruments will be sharper, our questions keener, our sense of wonder undimmed. So, as Atlas fades into the abyss, remember, the universe is not silent. It speaks in the language of rare visitors, cosmic riddles, and fleeting chances. Will you listen? Will you wonder? The next chapter depends on how we answer, here and now, in the shadow of the rarest visitor we have ever known.